From a security perspective, the worst possible scenario is when a website allows you to upload server-side scripts such as PHP, Java, or Python files, and is also configured to execute them as code. This makes it trivial to create your own web shell on the server. Web shell is a malicious script that enables an attacker to execute arbitrary commands on a remote web server simply by sending HTTP request to the right endpoint. If you are able to successfully upload a web shell, you effectively have a full control over the server. This means you can read and write arbitrary files, exfiltrate sensitive data, even use the server to pivot attacks against both internal infrastructure and the other servers outside the network. For example, the following PHP one-liner could be used to read arbitrary files from the other file system. Once uploaded, sending a request for this malicious file will return the target file's contents in the response. A more versatile web shell may look something like this. The script enables you to pass the arbitrary system command via the query parameters like follows. This one. Exploiting flawed validation of file uploads. In the wild, it's unlikely that you will find a website that has no protection against file upload attacks, like we saw in the like we will see in our labs. But just because defenses are in place, that doesn't mean that they are robust. You can sometimes still exploit flaws in these mechanisms to obtain a web shell for remote code execution. Flawed file type validation, it's when submitting HTML forms, the browser typically sends the provided data in a post request with the content type application form URL encoded. This is fine for sending simple text like your name or address. However, it isn't suitable for sending large amounts of binary data, such as an entire image file or a PDF document. In that case, the content type will be the form data is preferred. Consider a form containing fields for uploading an image, providing descriptions of it, and entering your username. Submitting such a form might result in a request that looks something like this. It's post request, image HTTP, host. You can see this kind of request type in the Burp suite. As you can see, the message body is split into the separate parts for each of the form's inputs. Each part contains a content disposition header, which provides some basic information about the input field. It relates to these individual parts may also contain their own content type header, which tells the server the data that was submitted using this input. One way that website might attempt to validate file upload is to check that this input specific content type header matches an expected type. If the server is only expecting image files, for example, it may only allow types like image JPEG, image PNG. Problems can arise when the value of this header is implicitly trusted by the server. If no further validation is performed to check whether the contents of the file actually match the supposed type, this defense can be easily bypassing using the tools like Burp Repeater. Let's talk about the preventing file execution in user-accessible directories. While it's clearly better to prevent dangerous file types being uploaded in the first place, the second line of defense is to stop the server from executing any scripts that do slip through the net. As a As a precaution, servers generally only run scripts meme type. They have been explicitly configured to execute. Otherwise, they may just return some kind of error message, or in some cases serve the contents of the file as plain text instead of this. This behavior is potentially interesting in its own right, as it may provide a way to leak source code, but it nullifies any attempt to create a web shell. This kind of configuration often differs between directories. A directory to which user-supplied files are uploaded, it will likely have much stricter controls than other locations on the file system that are assumed to be out of reach. For end users, if you can find a way to upload a script to a different directory that's not supposed to contain user-supplied files, the server may execute your script after all. It's some tip. Web servers often use the file name field in form data requests to determine the name and the location where the file should be saved. You should also note that even so, you may send all of your requests to the same domain name. This often points to a reverse proxy server of some kind, such as a load balancer. Your requests will often be handled by additional servers behind the scenes, which may also be configured differently.